Hello class. Today we are looking at all the different line segments and lines that we can draw in a triangle. So today's essential question is, how do I use the characteristics of medians and altitudes to solve problems? Your learning intention. I'm learning about the medians and altitudes of triangles and how to use them to solve problems. So you've got a warm-up question that has two problems. Given that L is the circumcenter of the triangle, find segments LM and LV. Okay, if you do not remember the definition of a circumcenter, get your notes out and look at it. Pause the video now and see if you can complete that problem. Well, I hope you paused and I hope you tried. The circumcenter has a special characteristics. The circumcenter is equidistant from all three vertebrae. So if this is 25, I automatically know two more segments. This one has to be 25 and this is centimeters, and this one also has to be 25 centimeters. Okay, what kind of a triangle do I have? A right triangle, so we can use Pythagorean theorem. So we know that AL is equal to LM, which is equal to 25 centimeters. If you notice, it is also the hypotenuse of this triangle. So to find LV, we'll apply the Pythagorean theorem. A squared plus B squared equals C squared. So 19 squared plus B squared equals 25 squared. Okay, I've got to get the B squared by itself. So B squared is equal to 25 squared minus 19 squared. The opposite of squaring is square rooting. So I will take and use the calculator and do it all in one step. First I find my square root. The square root button, you take the yellow button and then hit x squared. Now I need to put in 25 squared minus 19 squared. And I get 16.2488. So that is approximately 16.25. And that will be centimeters. For a lot of the problems we do in geometry, you need to have a little bit better handle on the number. You need to go out a little further to get more precision. So when we're looking at the lengths, especially with the Pythagorean theorem, a lot of times I will go out to the hundredths instead of the tenths because it gives you a much more accurate reading. So now that we go into today's lesson, we're starting with defining different terms. Geometry is about applying the definition of terms. So what is the median of a triangle? The median of a triangle is a segment whose. What do we know about the median of the triangle? It starts at the vertex, and it goes where? Median sounds like, almost like what number? Almost like middle. So your median has endpoints on the vertex and the midpoint of the opposite side. So it is a segment whose endpoints are a vertex and the midpoint of the opposite side. Okay, the point of concurrency of the medians of a triangle is called the centroid. You could have gotten it by looking down to the next term, the next thing we're going to explain. Centroid theorem, centroid. Okay, now, what is the centroid theorem? The centroid of a triangle has a special characteristic. The centroid is located 2/3 of the distance from the vertex to the opposite side. So you will have you've got the median going across. Part of the length of the median will be 2/3, and the other part of the median will be 1/3. So the centroid is located two-thirds of the distance from the vertex to the opposite side. Okay, now, way back when, you were learning how to find the area of a triangle. The area of your triangle is base times height divided by 2. The altitude of your triangle is the length of the altitude of the triangle is the height of your triangle. So what do we know about that altitude? What do we know about that altitude? To find it, we look for a special symbol that you'll find on the diagram. In fact, you have one right up here. What does that symbol mean? It means it is perpendicular. So it is a perpendicular segment from a vertex to the opposite side. You always, always, always have to look for your right angle to find your altitude. Okay, it can be located 3 different places. Guess what the first place would be? Inside. What is the opposite of inside? outside. If it's not inside and not outside, it is on. So, the altitude of a triangle can be inside, outside, or on the triangle. And the last thing we're going to define, the point of concurrency, the point where they meet up of the altitudes of a triangle, is called the orthocenter. So now we're going to draw the altitude of the triangle and find the area. Because this is on a Cartesian plane, it is easy to figure out what the length of the base and the length of the height is. You just simply count the boxes. So your area is 1/2 the base times the height, or I actually prefer base times height divided by 2, because then I can quickly see if I can factor out a 2, and I can make my problem a little bit easier. But you have to know the length of the base and the length of the height. So if I'm looking at the base, I count the boxes, or I realize on the x-axis I'm going from -2 to +4. There's 2 units here and another 4 units, so my base is 6 units. For my height, I can count them, or I can realize I'm going from -2 to +4 on the y-axis. So I've got 2 and then I've got 4 more, so my height is also 6 units. 6 times 6 divided by 2. Well, I can divide out the 2. 6 divided by 2 is 3. 2 divided by 2 is 1. So my area becomes 6 times 3, which is 18 units squared. If there's anything you're not understanding, please back the video up and watch the first part again. Okay, so how do we use the idea of centroid? Okay, I want you to look, this is your centroid. And if you notice from A to G, which is from your vertex to G to the centroid, looks much bigger than from G to E. This is where you know that AG is 2/3, GE is 1/3 of the length of AE. Same thing happens with the other 2 segments coming from the vertex to the centroid. So if we're looking at BF, BF is the whole length. GF is this smaller piece. So we know that GF is 1/3 of BF. So if BF is 36, I'm taking 36 and I'm divided by 3, which gives me 12, and that will be 12 units. So if it's a smaller side and you know the whole thing, you're going to multiply by 1/3. If it's a larger piece and you know the whole segment length, you multiply by 2/3. So let's see what AE is. AE is the whole thing again. We're looking for AG. AG is a bigger segment, so that is 2/3 of AE, which is 28. Can I simplify? Does 3 go evenly into 2 or evenly into 28? No. So I've got to take 2 times 28, and you get 56, divided by 3. Okay, that's an improper fraction. It does work. But a lot of the times we want to know what it is as a number with a fraction, as that compound number. So I know that 3 will not go into 56. Will it go into 55? No. Will it go into 54? Yes. So this is the same as 54 over 3 plus 2 over 3. "54 divided by 3 is 18. 18 plus 2/3 is 18 2/3 units. So, in the real world, not everything comes out as an integer. If it doesn't, then we need to decide if we want to leave it as this improper fraction or as a number with a fraction, that compound number. Okay, so now let's look at the next one. I want you to pause the video and see if you can figure out what to do. Okay, we're looking for CD if CG is equal to 12. Okay, so CG is the bigger one, the bigger part. CD is the whole thing. So we know that CG is equal to 2/3 of CD. Remember, it's in that 2/3 to 1/3 proportion, and we're looking for the whole thing. So we know that CG is 12. How do I get rid of a fraction? What do I multiply a fraction by to get 1? It begins with an R. You multiply by the reciprocal. So I'm going to multiply this side by 3 over 2, also by 3 over 2. I notice that 2 divides evenly into 12. So this will become 1, this becomes 6. 3 times 6 is 18. 18 is equal to CD, and that would be 18 units. Okay, AC if FC is equal to 5. FC is 5. What do I notice about AC? What do I notice about these two pieces here? Well, they're congruent. Those 3 tick marks tell me they're congruent. So AC is equal to 2 times FC, because we're looking at those congruent pieces. AC will be equal to 2 times 5, and AC is equal to 10 units. Okay, hopefully after this much practice you've got a good idea of what happens with the centroid. There are 3 more problems. Before you listen to my explanation, pause the video each time and see if you can figure it out. If you're unsure of your answer, don't write it down. Just sit here and think about it and then see if you're correct or not by turning the video back on. So pause the video now. As I'm looking at the first one, XK is the whole thing. So this whole thing is 27. Now, Is XQ the bigger segment or the smaller segment? It's the bigger segment, so that means XQ is 2/3 of XK. Okay, 2/3 of 27. If you need to, you can multiply by 27 by 2 and then divide it by 3. But 3 goes evenly into 27 9 times. 3 divided by 3 is 1. 27 divided by 3 is 9. So XQ is equal to 2 times 9, which is 18 units. Okay, so this time we know what AM is, and we're wanting to find MS. Pause the video again and see if you can do that. Okay, AM is 5. You look at it, it is the smaller piece. MS is the other piece. So this one is 1/3, this one is 2/3. What do you multiply 1/3 by to get 2/3? You multiply it by 2. So 2 times AM will give me MS. 2 times 5 will give me MS. 10 units is what the length of MS is. So each and every time you have to think of the way, what you're looking for. You have to think, is it the whole segment? Is it the larger part of the segment? Or is it the smaller part? Okay, so given G is a centroid, find N and the lengths. This is 2/3, this is 1/3. What do I multiply 1/3 by to get 2/3? Well, you multiply it by 2. So 2 times 3N will be equal to 5N plus 9. 6N will equal 5N plus 9. Subtract 5N from both sides. N is equal to 9. Okay, we're not quite done because we have to find those two lengths. So for the first one, the smaller one is 3N. That equals to 3 times 9, which is equal, 3N is equal to DG. (27 units is equal to DG. For the other piece, 5N plus 9 is equal to GB. 5 times 9 plus 9 is equal to GB. 5 times 9 is 45, plus 9 more is 54. 54 units is equal to GB. So what is the important takeaways? Your centroid divides the piece, the segment that goes from the vertex to the opposite side proportionally. 1/3 and 2/3. So you can use that proportionality to solve problems. So how do you know when you're successful? I know I'm successful when I can use the properties of medians, altitudes, and perpendicular bisectors to solve problems. Today we were looking at the centroid and the fact that it divides this segment into 1/3 and 2/3 pieces.